Right, so I think we can make a start. I've put this slide in here, not for, I don't think it applies to any of you now, but I know there's a couple of people I've had this conversation with, so I thought I'd put it in the video just to remind everyone that, you're laughing now, Liam, aren't you? Just to remind everyone to go into Google Classroom. That's got all the details for all the lessons in there. Yes, questions are quite often in Education Perfect, but what I'm finding more and more is the explanations in Education Perfect for some of the stuff aren't quite as good as they could be. So rather than us just taking the explanation straight out of Education Perfect, a lot of the time we're just doing the questions there, and I've either got an introduction video or some instructions by me, or a video or YouTube, something like that, just to explain a little bit more about the topic, because I think in some cases we can do a better job than just done in the straight EP explanations. So that's just important stuff. Make sure you're diving in there. Make sure you're looking at the things in order there. I mean, one of the things I can see here from my Finding Points of Intersection video that I recorded to start off that lesson, there aren't too many people who've actually seen that. It's only been looked at 3 times. So that was a video for the last lesson. Only 3 people have had a look at it. So just bear in mind, those things are there to help. Start off with a lesson, work through the stuff in there, and then it'll either jump out to EP or somewhere else. Right, we are going to start having a look at simultaneous equations today. I thought this was a good point to sort of just get together for a lesson. Quite a number of people on the surveys were saying that they'd find it quite nice and helpful if we could get sessions together and we could talk about stuff. So we're going to do this a little bit more. We'll try and do this at least once a week, just so that we can bring everyone together and make sure everyone's happy. So what do we mean by simultaneous equations, I guess, is the first question. Well, we've actually already been looking at this kind of stuff. If you've done the last lesson where you were looking at working out using algebra where the points of intersection of 2 lines were, you've already been doing simultaneous equations, even though you've not realized it. So if we had these 2 graphs, this is one of the questions in EP last time, and you look at where they cross, you're trying to figure that out, and I can see here it seems to be somewhere between 2 and 3 on the x-axis and somewhere between 3 and 4 on the y-axis where that point of intersection is. And you've looked at using algebra to work that out, okay? So finding where those 2 lines intersect is solving those 2 equations simultaneously. Simultaneous just means at the same time. So we're looking at where this equation, y equals x plus 1, and where this equation, y equals x plus 3, are simultaneously satisfied, are simultaneously true, and it's the point of intersection. That's all it is. And we did that little bit by algebra. That's what you're doing last time by writing 3x minus 4 is equal to x plus 1. Sorry, that's my phone. I just need to cancel that off. So 3x minus 4 equals x plus 1, and then work it from there. And if you've watched the video for the last lesson, you'll have seen that came out at 2.5 and 3.5. Okay, so that's where we got to from that, just by writing the 2 things equal to each other. And just by way of that as well, a little aside, I've got an example of some working around that one of you did last week. So one of the class, they're working in EP, was to solve something like that. They wrote the 2 expressions equal to each other, and then they said, fine, nice explanation here. They said, what do I need to do next? I need to take 3x away from both sides, because that's going to knock that bit out for me. That bit will go all together, and I get down to 4x minus the 3x is just an x. The minus 3 is still there, and the 1 is still there, just that 3x has gone. And then I'm trying to work back to what x is. I add 3 on. I've got x is 4. Okay, so it's that kind of idea. But we were looking at it last time from the point of view of thinking about equations of straight lines, okay, and thinking about the intersection of those. So that's really nice working, just by the by as well. For those of you struggling with what the working might look like nicely, that's really pretty good because it's explaining the 2 things equal to each other. We're getting rid of the x's on one side. So we take 3x, we have to do the same to both sides. So that becomes x. Everything else goes down onto the next line. Then we need to get the x on its own. We always do the opposite. So we're going to add 3. So just a little bit before we get into solving simultaneous equations generally, our straight line equations can quite often be written in a number of different forms. So if I'd got this straight line equation y equals 3x minus 4, I could write the same relationship between x and y like this. Y plus 4 equals 3x. Can anyone explain to me what I've done to go from that top line to this second line? Can you see what's happened? Yeah, I've just added 4 onto both sides. Okay? All that's happened there is I've added 4 onto both sides. If I add 4 onto the left-hand side, I get y plus 4. If I add 4 onto the right-hand side, it knocks out that take 4. So I get to that. All right? Can you see how I've done this one? What have I done to the top equation to get that one? Who can see what's happened? So in this one we saw we'd added 4. What have we done? Not taken away the 4. Can you see what we've taken away though, Liam? Yeah, we've taken 3x, haven't we? Yeah? It's now saying y take away 3x. We've taken away 3x there, and the 3x has been taken away on the other side. Yeah? That's all that's happened. There we added 4 to both sides. This second one, we've taken 3x from both sides. Yeah? What's happened on that one? Now, it might be easier to start from this one. Can you see from the second one to that one what we've done? The second line to the fourth line. Subtracted y. Yeah, exactly. That's what we've done. We've got rid of that y from there, haven't we? And it's become a minus y on the other side. All these 4 expressions represent the same relationship between x and y. Okay, if I've got a value of x and a value of y that satisfies this, they satisfy that, they satisfy that, they satisfy that. They are just other ways of writing the same thing. And a nice way for you to think about this sometimes is, if you're going to swap something from one side of the equation to the other, you end up doing the opposite. We had a minus 4 on this side, but when we swapped it to the other side, it became a plus 4. Yeah? We had a positive 3x on this side. When we swapped it to the other side, it became a minus 3x. And then looking at this one to the bottom one, I've got a plus y here. If I swap it onto the other side, it becomes a minus y. All right, so it's just a bit of that going on. Okay. So anything that looks like some number of x's plus some number of y's is some number, is a straight line. All of those things would give you straight lines. Okay, any of those things are straight lines. This internal, though, you don't need to worry about drawing them if they're given in that form. We only need to worry about the y equals some number of x plus something, that sort of thing. But all of those sorts of things are straight lines. The key thing for us, though, is to be able to solve them. So remember, these two things could be straight lines. If I want to solve them simultaneously, I've got to work out where they would cross. And I'm going to go through a method of doing that today. That's what we're going to look at. That's the focus. That's the skill for today. How do we start with things like this and work out where those lines would cross, where they would be solved simultaneously? Okay, so there is an algebra method that lets us do this. This does not rely on anything that you've done so far. So if you're not quite up to date with all the lessons, this doesn't rely on anything you've done so far apart from being able to solve equations. If you can solve equations, you can do this, okay? We just need to go through the steps and how we get it into the form where we're going to be able to do that. So this method is called the substitution method that we're going to look at. There are 2 methods, really, 2 big methods for solving simultaneous equations. We'll look at another one later on. This one's called the substitution method. And I'm going to go through this. I'm going to change to a pen and I'll go through this one with you slowly. So the first thing that we do whenever we're dealing, come back to where I was. The first thing that we do whenever we're dealing with simultaneous equations, we give our equations a name or a number in effect. So I call the first equation equation 1 and I write it like that. And I call the second equation, surprisingly, equation 2, and I write it like that. Now, if I look at equation 1, could you see, could I rearrange it so it just says y equals? Can anyone tell me what it would say? Equation 1, if I rearranged it. So it just says y equals rather than x plus y equals. Can you see what it would be? There's the 3 there, but I just want this y on its own. So, yeah, Liam. Yeah? You see what I've done? It's just what we were talking about before a minute ago. Really, if you take something across to the other side of an equation, you make it the opposite of what it was. It was a plus there, it's a minus on the other side. Or you can just think, I've done a minus. I've subtract x from that side, I've got to subtract x from the other side. Is that okay? Now I use my second equation, because my second equation says if I do 5x plus 2 lots of y, I get 12. But I now know that y is exactly the same as 3 minus x. So my next line says, do 5x, that's fine, we're not going to touch that at all, but where we had y, we're going to substitute, and instead of writing y, we're going to write what we worked out y is equal to on the line above. Okay? So all I've done is where I had y, I've written my expression for y. You see that's all that's happened? 2 times what y is. All right, I'm just going to rub a little bit out there because I don't like that bit on the bottom of my... So I'm just going to redo that bit. All right, so this is the important step really on here, to recognize that we can replace the y in that second equation by what we have said y is equal to, 3 minus x. Now this is an equation I can work with a little bit. When we've got equations within brackets, we want to get rid of the bracket. Do you remember how we get rid of brackets? Yeah, we times it out, Keely. Yeah, so I do 2 times the 3, that's 6. 2 times the minus x, minus 2x. All right, so all I've done there is I've simplified the bracket. 2 times 3, 2 times the minus x. Now I look to simplify this left-hand side, because I've got a 5x, but then I'm taking away a 2x. So how many x's do I really have? 3x, Liam, yeah. I've still got the plus 6, and it still equals 12. I think we can solve that from there, can't we? What would you do? Yeah, so that's what we're going to do, Ken. Take 6 from both sides. We're left with the 3x. And on the other side, we're going to take the 6 away. We're left with 6, aren't we? And what do you do to finish off? Yeah, divide by 3 both sides. X is 2. Okay, we now know that x is 2. We can work out, if I use equation 1, what y is. Because if I use equation 1 tells me x plus y is 3. Well, I know x is 2. 2 plus y has got to be 3 then. Y is 1. There's my answer. X has to be 2, y has to be 1. Okay? Now, we could have used this, by the way. If I bring this down here, look, the 3 minus x, I could just do 3 minus x there, couldn't I? Because it tells me y is 3 take away x. 3 take away 2, it's 1. I'd got my expression up here to say what y was, so I could just use that. Does it work? Well, it certainly works in the first equation, doesn't it? 2 plus 1 is 3. Let's have a look at the second equation, because we can always be sure with equations we're right or not. If I do 5x plus 2y, I hope I get 12. Does it work? Well, 5x, 5 times 2, 10. 2y is 2. It's 12. It shows me I definitely got the right answer. Okay? So the keys to this method, the keys to think about are, take one of the equations and rearrange it. So you could say y equals. Substitute that in to the other equation. So where we've got y, we're going to write the expression for y. Multiply out your bracket, and then you're on to doing equations that you know what to do with. Okay, so there's just a couple of extra steps in here, which is get your expression for y, then substitute that in. Everything else you've done before. All right, everything else in this you've done before. You've done multiplying brackets. You've done the solving equations bit before. All right, so it's getting y equals, substituting it in, multiply the brackets out, and away you go. Looking at my equation 1, do you think I could have chosen to do anything else there as my first step? My first step was to say y equals. Do you think I might have been able to choose to do something differently? Could I have said what x equals? I could, couldn't I? Couldn't I have said that x was 3 minus y? The same way that I said y is 3 minus x. I could have said x is 3 minus y, and I could have then substituted for x instead, if I wanted to. I'd then work out y first, yeah, because my equation would start out 5 lots of 3 minus y plus 2y is 12. It's still going to work, but I'm going to work out what y is first and then get x at the end. All right, with these simultaneous equations, this example, you've got a choice. You could either go for what y equals to start with, or you could go for what x equals to start with. They can both be rearranged out of that first equation. Okay? Any questions on that one? So we've still got it on the screen. Okay, I assume that's good. Let's have a look at another one then. So, we're going to go through, just like before, we give them a name. 1 and 2. Now, I think this time, if we look at equation 1, I think there's only one thing we're going to rearrange for to start with. Because it's not easy just to get what x equals, because that 2 in front of it, isn't it? Can you see from that first equation what y would be equal to if we were to rearrange it? Remember, when something goes on the other side, it becomes the minus of what it was. Can anyone tell me what y might be equal to? So I want the y on this side, really. It's going to have to go across on the other side to be positive. What's going to be left on the left-hand side? Well, the 2x will still be there, won't it? Won't it be that, Kian? That way round? Yeah. The y is going to cross onto the other side and become plus. The 7 will go to where the y was and become minus because it was plus. Yeah? That's just what we'll get. And then we'll go for the method just the same as we did last time. 5 lots of x plus now 3 lots of y equals 23. That's what equation 2 says. 5 lots of x plus 3 lots of y is 23. 5x, okay, that's fine. Can someone give me what the bracket expands out to? 6x minus 21. Okay, everyone see that 6x minus 21? 3 times the 2 makes 6x. 3 times the 7, and it's a negative, becomes minus 21. But I've got 5x plus 6x. That's 11x, isn't it? Minus 21 is 23. What's my next step? Plus 21. We're trying to get the x on its own, aren't we? Plus 21. We're trying to get the x on its own. We plus 21. 23 plus 21, 44. Final step, divide by 11. X is 4. Yeah? Now I am going to use this bit. I'm going to bring it down here. And I say, excuse me, I have an equation that says y equals 2x minus 7. Y equals 2x minus 7 is what that's telling me. So 2 lots of x, 8, minus 7, y is 1. X is 4, y is 1. Does it work in the second equation? Let's have a look. 5x plus 3y. 5 times x would be 20. 5 lots of 4. 3 times y, 3. 23 was the right answer. Okay, that's what I was after, isn't it? Should we go for another one? Yep. Ooh, this one hasn't changed very much, but it is a little bit different. So let's name our equations 1 and 2. So which letter are we going to rearrange for in equation 1? Y or X? Y again, isn't it, Liam? Because that one doesn't have a number in front of it, does it? And the Y will go across to this side to become positive, won't it? What's left on the left-hand side? 2x minus 3. Yeah. So the y's moved across and become positive, and the 3's moved across and become negative. Okay? Now we're away, aren't we? So our second equation says 5x minus 3 lots of y equals 23. Still the 23. 5x minus 6x. Right. Now, if there's going to be a mistake occurs here, this is where it comes. Have a look at that again and tell me why it's not minus 9. Yeah, it's negative 3 times negative 3. Positive 9. Okay, that's why I chose this one, to make it slightly different. The mistake that a lot of people will make on this, they'll do the minus 3 times the 2, okay, and get minus 6, but then forget this is minus 3 times minus 3. Okay, so just be a little bit careful there. 23. 5x take away 6x? What's that?
X.
Minus x. Yeah, I'd go for minus x. You see that, Liam? Yeah. Minus x plus 9 is 23. Well, now we can do the same sort of thing that we've been doing when we've been swapping things over. Let's make that a plus x on the other side. I don't like that minus x, do I? Really? The 9 is still there, but what has to happen to the 23? It does, doesn't it? It does, yeah. Right. The answers don't have to be positive. 9 take away 23. Minus 14. Always fall back and use your calculator if you're not sure. Remember, you've got your calculator. There's no problem with using that if you want to. But x here is minus 14. Go back to my equation for y. Okay, let's come back and see what this says for my equation for y. Because my equation for y said it was 2x minus 3. Up there. So I've got twice minus 14. That'll be minus 28. Take away 3. Minus 31. Yeah, not the friendliest answers here because they become negative, and this bit in here is the bit to watch out for as well. But does that work? Does that work? Well, let's try it. On our second equation then, whoops, I've lost everything there for a minute. Where's my mouse? There it is. So if I do 5, oh, I'm on the wrong one. I've gone back, haven't I? Dear me, where are we? I'm losing where I am. That's the one. 5x minus 3y. Let's see what we get. 5 times x. 5 times minus 14. Okay. No problem if you reach for your calculator for that, but it is negative 70. 5 4s is 20. 5 10s is 50. So it's negative 70. And then minus 3 lots of minus 31. Well, minus 3, it's going to become plus again, isn't it? This is a minus times a minus. 93. Oh, look. 23. Right answer. Because we have matched the 23. Okay? Right, because what's really happened here, I've really jumped 2 steps, and if you're happy doing what I've done, that's absolutely fine. Okay? If you're not so happy, then we can put an extra step in there for you. But what's happened, remember, this negative x has jumped over the other side and become a plus. Whenever something moves to the other side, it becomes the negative of what it was. Well, this 23 is now going to move, so it's not on the same side as the x. So it has to move onto the other side and becomes a negative 23. Yeah, the negative there becomes the plus there. The plus there becomes the negative there. When it moves across the equal sign, it changes from a plus to a minus. Yeah, now the extra step, if any of you did want to see the extra step, you could have done in there. Let me choose a different color. If I choose, whoops, my pointer is not behaving itself. If I choose, oh dear, really isn't. Right, let's come back. Ink color, let's go for blue. So where I had minus x plus 9 is 23, what you could have done is said, I don't like having the minus there to start with, so let's just add x onto both sides. If I add x to both sides, I've got 9 is 23 plus x, but I want the x on its own. Now can you see I've got to take the 23? Yeah, so that's just the same but in 2 steps. What we've done in red is those 2 steps in 1. We've taken the x across the equal sign and made it a plus, and we've taken the 23 across the equal sign and made it a minus. Okay? Good. Right. Actually, does someone want to talk me through this one all the way through? Who feels brave? Who feels confident? See what you can do. You can tell me what to do. I'm going to name them 1 and 2. There you are. I'll give you that bit. Then you've got to think which one of these in the first one are you going to rearrange for, X or Y? Which one does it make sense to go for here? We just want to go, if you remember, Liam, for the one that doesn't have a number in front of it. So x is going to be equal to 7 plus 2y, did you say? Yeah? Is that what you said? So 2y comes across the other side and becomes a plus. X stays where it is, 2y moves over, and that was a negative, wasn't it? I missed a negative. Was someone thinking, he's gone wrong there, and I'm not going to tell him. There's a negative 7 there. Yeah? If you want, by the way, would you be happy with me doing this? Just reordering that and writing 2y minus 7? You happy that those 2 things are the same? Because if I add 2 numbers, I can add them any way around I like. 3 plus 5 is the same as 5 plus 3. I just write them the other way around. It's fine. Okay, all I've done is swap the order. I've written them around there. All right, let me carry it on then. We'll finish it off. It's going to go a similar sort of way. So this one, we are replacing x. So I've got 5y minus 6. What we've now said x is 2y minus 7 is 28. This is the second equation. 5y, what comes next? Yep. You sure it's a minus? Yeah. Two minuses together again there, aren't there? The minus 6 and the minus 7. Plus 42 is 28. Okay. 5y minus 12y, minus 7 lots of y then. Plus 42 is 28. Right. Who can do the swapping over step for me? Because we've got the y's on this side. I really want positive y's. So if I bring them over here, make them a plus on the other side, what happens back on this right-hand side? What happens? Minus 28. Good job, Liam. That's 14. Divide by 7. Y is 2. And we had our expression for x. So let's bring him back down here. Our expression for x says that x is 2y minus 7. So our expression there, 2 lots of y, that's 4, minus 7 will be minus 3. So we've got 2 and minus 3 there. Does it work? Right, this is what we've been checking, haven't we, all the way through? So we've got 5y minus 6x in the second equation. 5 lots of y is 10. Minus 6 lots of x. Minus 6 times minus 3 is 18. 28. Done. Okay. How are we feeling? Doing some is going to make the difference. Having a go. Okay. The new stuff that we've got in here today is this bit. Doing that bit where you look at one of the equations and either go for x or go for y, depending on what has the 1 in front of it. And if you've got a choice, you've got a choice. And then it's multiply the bracket and just go with your equation. But always have a little check at the end. Yeah, basically your choice is going to always be based on what you've got here, Keely. So on this one, okay, if I go to the laser pointer, this one, there's no number in front of the x, so I'm going to rearrange it so it says x equals. There is a number in front of the y, so I'm not going to rearrange for that. If it said x and minus y, I'd have a choice. Which one do I want to go for? And it really is up to you at that point. It doesn't make any difference. You'll get the same answer, but it'll just depend on whether you're working out x or y first. That's all. And then once you've got that, you can work it through. All right? So this stuff here is getting into really sort of high-end stuff. All right? This is not achieved. This is getting beyond that. Okay? But it is certainly worth having a go at, even for those of you who might be thinking, well, achieved's good, I'll be happy with achieved. It's worth having a go at because it practices the algebra skills that you'll need anyway. Yeah, these algebra skills it practices that certainly are achieved, but this bit is a bit more than that. It's about putting that extra step on the beginning. Okay, just very quickly, we're not going to do these ones, but I just wonder, if I give you a couple of minutes just to give all of you a chance to have a bit of a think. So there are 3 here. All I want to know is, which letter would you rearrange for first in each one? Which one would you rearrange for in the green one? Which one would you rearrange for in the orange one? Which one would you rearrange for in the red one? All right, give you a minute. Have a little look at them. and we'll see what we think. So you're going to rearrange for X or Y in each one. Okay, who's brave? Who wants to have a go? Who thinks they're confident they could say all three? Anyone? Oh, you're going for it, Liam. Go on then. What would you go for in this first one? Yep, definitely X. There's no number in front of the X, is there? Go for X. What would you go for in the second one? Y. No number in front of the Y. Go for Y. What would you go through in the red one? And Y again. No number. All right. That first step should be that easy to identify. Which one's got no number in front of it? Yeah. X equals, you've already got the 1 there. You're getting rid of that 3Y. What's it going to be on the other side? Keely? Yeah, that's it. That's how you'd rearrange for that first one. This one, what would go there? 4 minus 6X. Yeah? And this one? Yeah. Okay. So, recognizing which one to go for, which one doesn't have a number in front of it. That's it. And then you're trying to keep that bit on its own. Remember, everything else, when it goes across to the other side, becomes the negative of what it was. That 6X becomes a minus 6X. That's it. Then you can substitute in. So then if I was doing the orange one, I'd just start with my substitution and go 5X plus 2 lots of what I know Y is. 4 minus 6X equals, sorry, I'm not even writing the right, 4 minus 6X, that's right, equals 1. And go from there. Yeah, 5X plus 8 minus 12X is 1. 5X minus 12X minus 7X. Minus 7X plus 8 is 1. Take the 7X to the other side to make it positive. The 1 has to become negative then, doesn't it? To go the other way. Oh, look, 7X is 7. Divide by 7, X is 1. Once you've got X, there's your expression for Y. Y is 4 minus 6 lots of X. Y is 4 minus 6 then. Y is minus 2. Done. Okay? Yep. It's getting into both. Okay, it depends what you do with it afterwards. Because if you remember what we talked about before, Keely, the excellence start kind of thing really kicks in when you start to relate it to a context. Yeah. So that's great. That's all good. Right. We are going to have a bit of a play. All right. A little bit of a quick play. So if you've got a calculator, you've got a pen, you're good. If not, if you haven't got a calculator, you might want to go for this desmos.com scientific. It's really good. You just get a scientific calculator on your screen. You can play with, do whatever you like. All right, desmos.com scientific. Everyone got your phones? I suggested you bring your phone. If you haven't got your phone, you can kind of do it on your computer, but it's not as good because you're going to struggle to see the questions a little bit. You have to flip between 2 tabs on Chrome, so you're going to have to see what I'm doing, and you're going to have to see what it's asking you for. Okay, so what you need to do is to go to, on your phones, if you have your phone with you, go to drfrostmaths.com join. Go to that website. drfrostmaths.com join. It will give you a code. It will ask you for a code, and I'll give you that code in a minute. Dr. Frost, maths.com join. All right, can you see the code? Or do I need to share that with you? Are you seeing the code or not? Right, okay, I will share that with you. Hang on a minute. You got it now? Okay, type that code in. Join as a guest. And just enter your name. So it's a bit like Kahoot, this. So Keely's in. And Jesse, excellent. We're getting a Kian. Charlotte's in. Who else are we waiting on? Who else is here? Are you struggling to get in, Liam? Okay. All right, you must have joined if you can. Are you going to join us, Nico? Oh, yeah, I've been awarding those all the way through. They're all happening. So typically what you'll see, you know you've been getting, obviously I'm awarding stuff in EP, aren't I? So you'll get all the points coming through there, but I'm doing the dojo points as well. So they're all going through. Are we nearly there, Nico? Okay, so there we go. Right. Okay, guys. So questions will appear on my screen. You answer them on your phone. Here's your first question. So you can join in at home even if you're not on the phone. Have a think about it. Okay, so the answer was yes. All right, so you'll see what you've got through there. Let's go to the next one. Okay, good job. So that was a no because it was a 10x. It didn't say minus 10. And it had been minus 10 before. What about this one? Excellent. Seeing lots of 1,000 point. Everyone right. Brilliant job. Right, here we go. Good job. Yeah. And our next one now. Let's have a look at this one. So you've got the options on your screen. If you're not connected on the phone, have a think. What do you think might be the best ways to rearrange to start with? What would be a good first step? But select all the answers you think could be correct. You've got a few on there on your phone. More than one of them is correct. So there were three options there that could work, because you could subtract the x away there and have y equals 2 minus x. So that one's okay. You could subtract the y away and have x equals 2 minus y. That would be okay. And in the second equation, you could have subtracted the 4x away and had y equals 11 minus 4x. So there were three options there. So well done if you got all three. Oh, that was you, Jesse. Well done. Right, this one is asking you to work out the answer. So I'm going to give you a little while. We're going to finish on this one. Let's see if we can go out in a storm. Can you work out what x is and what y is? You'll definitely need to write this down. How are we doing? We're nearly there. Oh, Charlotte, you were there. Excellent. Oh, Charlotte got it. Excellent job, Charlotte. Right. Okay, we're going to finish there. The way to go about doing that one, I would have probably just said that x is y plus 7. You would get then 3 lots of that. So you're going to get 3y plus 21 plus another y is 33. 4y plus 21 is 33. 4y is 12. Y is 3. And then back to here, x is 7 plus y, x is 10. So we're going to finish there for today, guys. It will give you the final standings. Ooh, close job. Well done, Jesse. Nailed it. Good job, guys. So what I'll do, I'll put some questions through on this for the next lesson, just so you can have a bit of a practice. But yeah, hopefully it's been a bit of a different lesson today because we've been able to talk over things and have a look at stuff. Has that been okay for you guys? We're going to do some more stuff like this. Yeah? Yeah? Do you enjoy the quiz? Was the quiz fun? Feel the pressure? Yeah. Okay, guys. Have a good one. Thanks for joining today. See you next time.